morning, everybody. Morgan here. We're going to be talking about the homework called Redox Reactions number 4, Electrochemical Cells today. So we're going to start off with this question: what is an electrochemical cell? And we're going to say that it's any device that operates on, or maybe we want to use the word with, or even based on a redox reaction. And that is, in essence, what we would call a battery today. Okay? So, inside of that, which chemical change will happen at the anode? The anode will be the oxidation. And notice that both anode and oxidation begin with vowels. At the cathode, we have reduction. And both cathode and reduction start with consonants. Easy way to kind of just nice thing to keep them straight there. So, what's the purpose of the salt bridge? Well, if I'm playing physics to teacher, the physics teacher in me wants to say that it completes the circuit. The chemistry teacher in me says that it allows for the backflow of charge, or it helps to balance the charge. Okay. The unit of electric potential, we said, was the volt. Okay. Now, inside of an electrochemical cell that operates spontaneously, which is what we might call a galvanic cell, the electrode that is positive is the cathode. And I've spelled it kind of a funny way there, using a positive sign rather than the T in cathode, which means the negative electrode would be the anode. Okay? Now, by definition in this country and most countries all over the planet, the positive wire is red and the negative wire is black. And you will notice this looking at the battery under the hood of a car. And on most batteries, if you clean up the battery post itself, you'll actually see a positive sign or a negative sign etched into it. And the big cable that goes to the positive one is the red one. Okay? So now, all of the reactions whose EMF is a positive number are what we will say are spontaneous reactions. They happen on their own. Okay? So what we're going to do next then is draw a picture of an electrochemical cell. And in this question, I specifically said to talk about zinc and silver. Okay? Write the overall spontaneous reaction that occurs, calculate the EMF for the cell, label the anode, the cathode, the salt bridge, the ion flow, the flow of electrons, positive electrode, negative electrode, which one grows, which one shrinks, etc., etc. So a pretty detailed picture here then. So I'm going to need to have 2 beakers or cells involved here. And of course they will be connected with a salt bridge. And I'm going to put in some, say, potassium nitrate. Any good soluble salt works nicely. Okay? So now, I need solution in both sides. That actually I extend down into solution, sorry. I need solutions in both sides. Over here and over here, I'm going to have a piece of metal. So we'll make this one the silver, and we'll make this one the zinc. And what we will do is connect those pieces of metal with a multimeter. That'll just be typical wiring with little alligator clips on the end. Now, because this metal is silver, this has to be Ag plus. NO3 minus is something that silver is soluble with. Over here, zinc 2 plus, NO3 minus. Okay. Now, I need to figure out which way the spontaneous reaction is going to occur. And then I can figure out all the rest of that stuff. So I'm going to come back here to my table of reduction potentials. And here I've got the one for silver, which is 0.80. And then I need to find the one for zinc, which is down here. I'd already found it, which is negative 0.76. Now, I want this to be spontaneous. So I need to put these together in such a way that the overall answer is going to be positive. Now, this one, if I reverse it, the negative becomes a positive, and both those values would be positive. Hey, yep, that's going to work. That's going to give me the positive reaction. So my reactions are going to be Ag plus an electron to give me Ag, and Zn to give me Zn2 plus 2 electrons. And the balanced reaction, Ag plus an electron to give me Ag. I looked up and that was 0.80 volts. I'm going to need to put a 2 on each of those, but that doesn't change this value. And then Zn gives me Zn2 plus 2 electrons, and that E naught was 0.76 volts. Now, the 2 electrons here and the 2 electrons there are on opposite sides, so they're going to cancel. And I have 2 Ag plus zinc gives me 2 Ag plus Zn2 plus, and that should be 1.56 if I'm doing that correct in my head. 0.80 plus 0.76, and I get 1.56 volts. E naught equals 1.56 volts. Okay, so now changes that are going on. Zinc is losing electrons, so the electrons are going to go this way, which means that given time, the zinc is going to become a smaller piece of metal, and the silver is going to become the larger piece of metal. This is being oxidized, so this is the anode, and by default that makes this the cathode. Okay, now the anions always flow towards the anode, so since I'm getting more zinc 2 pluses over here, nitrates will come out of the salt bridge, and on this side the potassium ions will come out because I'm going to have an excess of nitrates as all the silvers go up and form the solid silver that's on that electrode. This is going to read 1.56 volts as long as this is at 25 degrees Celsius and all the concentrations are 1.00 molar. Okay? Now, since the electrons are flowing away from here, this must be the negative side, and since they're attracted over here, that must be the positive side. So I have the overall spontaneous reaction. I have its EMF. I've labeled the anode and the cathode and the salt bridge. I showed the ion flow. I showed which way the electrons are flowing. The ion flow out of the salt bridge, the K plus this side, nitrate over there is what I meant back there. Okay. I showed the positive and the negative. I showed which one grows and which one shrinks. So I think I've got everything that I was asking for in that diagram. All right, so let's flip over here to the back. Okay, so in this cell, the reaction is involving zinc and magnesium. So one of these is zinc and one of these is magnesium. Okay, there's KNO3 in the salt bridge, and the way I'm seeing these arrows, they're going this way, which means this must be the anode. Okay, this must be the cathode. So I need my EMF table to check this out. Magnesium. Magnesium's all the way down here in my EMF table. Its reduction potential is negative 2.37, which means its oxidation, Mg going to Mg2 plus 2 electrons, 2.37 volts. And then the zinc one would be going the other way, zinc 2 plus 2 electrons to give me zinc. Earlier I found that that was negative 0.76 for a reduction, so negative 0.76 volts. I'm going to add those together, 2.37 minus 0.76, and I'm getting 1.61. Okay. So that must mean that this E is the magnesium. Okay? Now, A was this side, E was that side, so E is magnesium, A is zinc. Okay? That means that B is the zinc nitrate, and D is the magnesium nitrate. That means that the nitrate ions out of the salt bridge go this way, and the potassium ions out of the salt bridge go that way. Okay? And this meter would measure 1.61 volts. So in essence, this question right here, Mg plus En2 plus yields, where I want to calculate the EMF, is this right here. It's Mg goes to Mg2 plus 2 electrons, 2.37 volts, and Zn2 plus 2 electrons gives me Zn. E naught equals negative 0.76 volts, and that adds up to 1.61 volts. And since it's positive, we say this is a spontaneous reaction. It happens without outside help. Now here, Fe must be turning into Fe2 plus 2 electrons, and Zn2 plus 2 electrons is turning into Zn. I already know that E naught is a negative 0.76 volts. The one for iron I can find in my table. Fe2 plus, that's an Fe3 plus, not interested in it. Here's my Fe2 plus to Fe. As a reduction, it's a negative 0.44, but I'm using it as an oxidation, so it's a positive 0.44 volts. So on my calculator, when I take negative 0.76 plus 0.44, I get negative 0.32, and it is not spontaneous. It does not happen on its own. Okay, so there you go. That is redox number 4. I'll leave a few more of these for you to try on your own. And then I think we are scheduled to be collecting this on Wednesday of this week. And Wednesday would be April 29th. Okay, hope you're having a good Monday. This is Morgan signing off.